That is again a 0 because nothing is happening. And of course Fw is written as, let's see if I find some space here, Fw is written as mass times gravity, mg. There we go. Both of these positive numbers, the negative number comes from this sine 270 degrees. Okay, they want us to figure out what the tension is. So this one here. So that's one of our variables. And they want us to figure out what the theta is, respectively. For now, I'm using the alpha. By the way, I think you can see this, that alpha equals 90 degrees plus theta, right? Because up here would be the vertical, and then this little piece in here would be theta itself, and then 90 degrees there. Okay. So actually, oh yeah, I wanted to circle that alpha. There it is. Okay, let's see where we get started. We have both variables in both equations, so we have to eliminate something here. And the easiest way to do that is to get just these parts on one side of the equation and then the other parts on the other side of the equation, and then divide, because when I divide that with only this stuff on one side, the ft will divide out. And I will divide the y by the x, and you will see in a moment why I do that. Okay, I'm not going to change the color at this point. So ft times sine alpha, that was supposed to be an I, and that equals negative fc. Notice that fc actually will be a positive number as it points to the right, but of course I brought it to the other side, so that introduces a negative. And then ft times cosine alpha equals, and the sine 270 degrees here already is a negative, so it's a negative Fw. So when I get it to the other side, it actually becomes a positive Fw. And as I said, now I divide both sides by each other, and that double equal sign there looks a little strange, but that's alright. And notice what happens, of course, on the left hand side. As I said, what divides out is the ft, and what is left behind is sine theta over cosine theta. Why did I do the y divided by the x? Because I saw that sine divided by cosine will give me a nice tangent. Otherwise I would have gotten a cotangent. Would be still okay, but I would have to do some more algebra. Equals negative fc over fw. And at this point I would have to plug in numbers in order to get the alpha. Of course, what I would have to do here is divide here, put a negative in front of that, and what was I going to say? Oh, take the inverse tangent of that. But instead of writing that all down, all these long numbers, I might as well do it on a graphing calculator and show you. Saves me some space here to write it down, and a lot of effort too for me to write it down with this tablet. So let's see what I get here. Okay, there's that negative. Then in parentheses, I'm going to put the 8.99. Is that really rounded 8.99, or do they do 9.00? Sorry, I'm paging. I have to actually look that up. Yeah, they keep using 8.99. Okay, to the 9th, and then times, there's that one charge, 0.6, I go back, 0.600 microcoulombs, which is -6, times 0.900 and it's also my coulombs also -6. Okay, notice that right here I omitted that negative, and I did so on purpose. I'm just using the magnitudes. The reason is that my Coulomb force, this one right here, is pointing to the right, and so I need to come up with a positive, and I can only do that if I use the magnitudes of these two charges. Okay, divide that by the distance between the two, and that is 0.150 meters, and that needs to be squared. Then there's that fraction bar, and in the denominator I have the mass of this one here, which I have to look up in the problem, is 0.08 kilograms. 0.0800 kilograms times the acceleration due to gravity, which is 9.8, parentheses, put another parentheses, hit an enter. I do come up with a negative, again because of this negative, and that makes sense because once I take the inverse tangent of that, it has to put me in the second quadrant where the tangent is actually negative. Let me first check that I am in degrees. I am. So I'm going to take the inverse tangent of that number. Oops, made a mistake. Try it again. I hit the wrong button. There's the answer. I hope I didn't mess up. -15. Okay, it's actually putting me into the fourth quadrant. -15 degrees, which means this here actually should be 105 degrees, respectively. Actually, this one here without the negative is that theta here, 15 degrees, 15.4 degrees. As I said earlier, it's 90 degrees plus the theta, and again, it put me actually into the fourth quadrant rather than into the second, so that's why you see that -15 there, and the other result would have been 105.4 degrees, which still makes the theta to be 15.4 degrees. So here it is. Okay, and then actually you take just one of the two equations, and let's see, what color do I have left over here, and you plug in for Ft. So you're going to do Ft equals, I'm going to use the easier one, the second one here. Again, bring that Fw to the other side, and because here it's a negative right there, it's a negative, bring it to the other side, it becomes a positive, so it's Fw respectively just m times g, and then divide by sine theta. I'm not going to hold up here with explaining the algebra, of course you should know that. Sine alpha. Oh, take that back, take that back. Now I should erase things, or should I? Because my alpha is actually 105.4 degrees and my theta is 15.4 degrees. I have to fix that, and I don't want to do the whole recording over, so let me think about this a moment. That one is actually 105.4 degrees. I put that entry there in the wrong place, and then this one here is theta equals 15.4 degrees. That's what I meant to write. And then actually here it doesn't really matter if I use the alpha of what? Let me think about this. Yes, it does matter. I have to use actually the alpha of 105 degrees because that's how I defined my vertical force Ft. And so that is going to come out to, let's see, sorry, I'm back to green here. Now that I confused myself here for a moment, I might as well finish the problem. So I might as well finish the problem since I confused myself here for a moment, writing down these here, the degrees. So it's going to be the tension equals 0.08 kilograms times 9.8 meters per second squared, gravity, divide by the sine of alpha, which is given as 105.4 degrees. So I have to correct here in the calculation to the alpha that I had used. Enter, and the result comes out to 0.81, what was that other decimal? 3 newtons.